All right, I think we're live. So we've got
Okay,
a group of type designers on the call here today to chat with Ben Bauermeister, who was the inventor of the PANOSE type classification system and went on to create a kind of font synthesis and compression system. And the company that he founded for that was eventually sold to Hewlett-Packard for use in printers in the early 90s. And so Ben has a presentation about that work that he did in the past, and then he's also going to present his new work that he's doing this year on applying the PANOSE model to Devanagari.
great. So can people hear me? If you just sort of nod, I'll see. Oh yeah, there's a bunch of nodding. Good, good, good. Okay. This talk is about PANOSE and also about Infinifont. Infinifont was the font synthesis engine that was built based on the PANOSE classification system. So that's what we'll cover today. I'll try to keep it brief. If you have questions, please speak up or type up or something. But we'll try to get those answered. So PANOSE was invented in 1982, so a long time ago. I was very young then. I'll say that, and it had to do with I was taking a studio art course and was asked to go find some letters for this poster for Richard Diebenkorn, who's a modern painter who was hanging a show, and yeah, he's a winner, and my professor of the class said, I need you to go find some letters that are sans serif and black and wide for this vertical poster. And so I went to the art store and I asked them for a sans serif typeface that was very heavy and very wide. And they gave me this huge stack of books and said, well, start looking through it. And when you find one you like, let us know. And I said, there has to be some sort of a classification system for type where I can say, give me the sans serifs, give me the heavy ones, give me the wide ones. And they said nothing like that exists. So at that point, I started to think about that as a process for how to classify type. I'd just taken some botany courses, and in botany, there are these tree finders where you can just take a leaf and count the tips of the leaf and say whether it's jagged or say whether there's 3 leaves per stem, and it will tell you, you're holding poison ivy, and that's a handy thing to know. So I thought that a similar thing based solely on visual characteristics could be interesting for type. As I researched it some, I found that there were a number of different type classification systems, but all of those you already had to know a lot about type to even use the classification system. You had to know what transitional meant and what the old style, character shapes were and things like this. And I wanted it to be based purely on the visual classification. So I built this database and in 1985 published this book, which was called the Manual of Comparative Typography, based on PANOSE. And this was right at the dawn of PostScript in '85. Most of this book was still laid out by hand. I had to cut all these deals with all the different type companies to have them give me samples of type, and then I had to glue them all up. There's only one page in the whole book that was done using PostScript, and my publisher thought I was some sort of mad science genius sort of thing that I could put together this page that was a page inside of a page and had call-outs, and there was no glue marks and no blue lines on it. It was really revolutionary. So that's kind of the time period that we're at when PANOSE first started. In the book, each font family has a number, so it's family based, and it's a 7-digit number that covers about 7 different characteristics. And we didn't cover weight, we didn't cover italics, so it was a fairly simple and rudimentary system at that point. Oh, and why PANOSE? At that point, Pantone was already out for matching colors, and I thought, I could ride on their coattails and do a little brand infringement, and maybe that would make them want to buy my system. But that didn't turn out. The actual selection of those letters was that I knew that my book would have single-line font listings, just like lots of font specimen books do. And rather than specifying the type in the name of the font, which is often the case, I said I wanted to have the same letters every time so you could actually compare two fonts to each other and know that you're actually comparing apples to apples. And so, it has a full round with the O, it has a double round with the S, it has a double square with the E, it has a full square with the N, a half round with the P, and a full triangle. So it gives you a little bit of a sampling of what's going on in the font repeatedly again and again. So that's where PANOSE came from as a name. What happened then was the book was out there. I got a job doing tech support for PageMaker back in the day, if you remember that old page layout program. And the Mac was picking up. There were image setters. And Microsoft finally was starting to get into the type game, and they wanted to be able to have a system that would map their faces, Arial times New Roman, Book Antica, Century Gothic, with the Mac's faces, the PostScript faces that were Avant-Garde and Helvetica and Times Roman, Palatino. And so they saw my system and said, can we make it more precise so that it covers families and italics, and can we make it so that then there's mapping between the fonts that are on my system versus the fonts that might be on the printer, or the fonts that are in a document versus the fonts that are on my machine. And so PANOSE for Microsoft was born, and that was great. It was 10 digits. It had 16 different classification metrics, and each one of those metrics was then very precisely defined for what you measure on the type and how that gets classified, right? So it was what was a very vague system had become a very refined and numerically measured and classified system. And probably the most important thing was in that red book, back here on page 9, there was one phrase in the text that said, "Remember, this book can quickly locate a typeface for you, but at this point, it cannot design one. Maybe next year." And that I typed that kind of in a late night stupor, throwing the text together, and that stuck in my head. And for the next several years, I thought, if you had a room full of typographers and you gave them each the same 10-digit number that has these same classification specifications, and asked them each to design a font that matched that number, how different would those fonts be? Well, they would be a little different. The way that you bend the leg of the R might be different. The way you detail the lowercase y or z might be different. But at a distance, if you put them all up on the wall and stood back, they would have the same tone, they'd have the same color, they'd have the same overall structure. And so I thought, why can't we just write a set of software programs that know how to look at that number, and from just that simple 10-digit number, put out a type 1 typeface. And so that's what Infinifont was. So this was then in 1992. Type was very popular at the time for the first time in history. People kind of cared about fonts and were looking at fonts. PANOSE 2.0 was then taking what we always refer to as bucket values. So there's this bucket that says your medium weight, and that's a range of this to this, and there's this bucket that says your bold weight, and that's a range of this to this. Instead, PANOSE 2 said, this is your weight ratio. This number is the ratio of your cap height to your stem thickness. And so every value that was in there was now a discrete setting. And so we took that PANOSE 2 specification and built this whole font development environment. The program was called the Terrafont. which was interesting because no one had started to use the word terabyte yet. I mean, terabyte was still way out in the future somewhere, and the fact that, you know, my business partner Clyde McQueen said, you know, this is like a billion, this is like a terafont. I mean, you know, and it just stuck. So TSL was the Terafont source language, which was the language that we wrote to do all this development in. The IFE was the Infinifont font engine, which actually spun up. That was a little tiny runtime. It was about 350, 400K that would spin up any of these PANOSE numbers into full font files. And Pecos was the place that the kind of designer studio where we worked in for software. The interesting thing was that we were building this as a font designer's tool where you could stick in a number or set a couple knobs and hit the go button, and it would give you a mediocre typeface that you could then take into a font editor and clean it up, right? But it would at least all be consistent. It would be well laid out. Your stems would be built for you. It would have this consistent look. And we referred to that as a germ font. And the germ fonts were the generic engine response metrics. So that was just a font that came out of thin air. And HP came and talked to us about it and said, instead of doing an infinite number of mediocre fonts, could you use this system to do, say, 45 fonts dead on? And I said, no, of course not. That couldn't be done. You know, that wasn't the direction we were heading. And my partner Clyde said, well, we could just keep adding descriptive values to that 10-digit number until we've captured everything about the face, and it probably isn't that many. And he was right. As it turns out, you know, you have to scoot the bowl of the uppercase P up a little bit, but that's a lot less data than every X and Y point all the way around the whole curve of the font, right? And so we ended up with something that HP could use to re-render all of their typefaces in the LaserJet. And we were eventually embedded in the LaserJet 5P. And the interesting thing there was that this was at a time when RAM was very expensive in a printer. So their 45 faces took up 4 megs of printer RAM, custom burned, and ROM chips, and they were about $4 a chip. So they were spending $16 per laser printer just on the ROM, and with ours, we gave them 120 fonts inside 1 megabyte and a much wider character set. And so our technology ended up saving them about $12 a printer. And if you're shipping, you know, close to 1 million printers a month, which is what they were doing back then, it starts to look like real money. I wish they would have just given all that money to me, but they had other plans. But they did end up buying the company, and that was a happy thing. So the other places that we went to, this was, I don't have a lot to show on this. I wish I had a sampling of some of the characters, but their marketing department came to us at one point after Infinifont had been finished and said, now we're getting requests for Cyrillic typefaces. It was an additional 86 glyphs that they needed across the 120 fonts, and we were able to build that and develop it with fully hinted TrueType and Type 1 outlines in about 4 months of development time. And it only made the overall solution about like 160K bigger. So it was just a really fun testimonial of kind of this strength of once you start to get the synthesis engine and the base outline so that they know how to behave, you can throw new characters in there and they behave properly as well. You can throw an N in that kind of looks like a backwards N because it's a Cyrillic letter, and it can come off of all the same overrides that were given to the uppercase N and do something that's interesting. So we also, this is the sad part of the story, we also did a great piece of development research on kanji and CJK faces. We built over the process of about 3 years a great relationship with Murasawa, who's leading typographic design firm in Osaka. Mr. Murasawa invited Clyde and I up to his tea room, and we had tea, and there was lots of bowing, and there was exchanging of weird little gifts and things that we didn't know if you were supposed to pin them on your lapel or eat them. You know, it was sort of those sorts of things. And at the end of it, we get this letter saying, you know, we want to do business with you, and the basic division of labor was going to be that we would build the technology and provide the replication services, and they would provide the typographic expertise, you know, the native eyes on the project that we didn't have, and there would be a revenue share. And the cool thing was we were looking at for an imprinter in a laser printer product, the ability to do 12 fonts, so 3 families, kind of a serif, a sans serif, and a slightly rounded one in 4 weights, and do that in less than 4 megs. And anyone else who was looking at 12 fonts of CJK at that point was looking at, you know, somewhere between 70 and 100 megs of data. So that it was.
And you'd still be looking at that today, right?
And what's that?
We'd still be looking at 100 megs for 12 fonts.
Yes. Yeah. Yeah, exactly. I mean, that's the amazing thing, is that it's still an opportunity, right? No one has really taken on that. I mean, it's a huge development effort. Don't get me wrong. It was going to take us 2 years and a team of 15 or 20 people, but it was going to revolutionize. It was going to really put into a different context the way that market was exposed to type. And when HP bought the company, we said, this is worth millions and millions of dollars. And they said, well, we'll ask our marketing department. And the marketing department came back and said, well, we talked to our customers because we're customer centric. And our customers didn't mention anything about wanting more fonts. They want less paper jams. So we're going to focus on fixing paper jams. And I had to go write Murasawa this note and just say, sorry, they're pulling the plug on it, which drove me crazy. But that was HP's decision, and the fruit is still hanging on the tree for the first person who can jump high enough to reach it. So that's a fun thing. And then there's the work that I'm working on now with Dave and some of you, which is the Devanagari system for PANOSE. PANOSE did have, in the very early days, a Kanji system. We looked at an Arabic system and a Hebrew system at one point, but those were never developed. And so it's kind of exciting to look at this and do the work for making it appropriate to Devanagari and also compatible into the PANOSE system. So at the end of this, you could say, I've got Times Roman, what's the best aesthetic match of the fonts, of the Devanagari fonts that are on my system, that's going to lay out well with that Times Roman, and it could do that matching. Similarly, you could have a Devanagari face and say, of all the fonts that are on my system, Latin fonts, which one is the best stylistic match to the Latin that I have? So you can work things in that way. So that's I think, yeah, the kind of PANOSE overview. I put together a fast and ugly deck this morning, but it's just a chance to kind of walk through the Devanagari work that I'm doing, so you can kind of see how that lays in. So I'm going to see if I can open that up. To just take me a second. I think I'll probably have to re-screen share.
I think if you open the file using that instance of the Finder, that's one way.
Should it work? If not, I'll just reshare. I think it was a long time ago that I named this file. Where did I put it? Hang on. I'm going to go this way.
I think it was Latin Devanagari PANOSE.
Yeah, I got it. And let me come back over here, and I think I do have to. I'm gonna. Screen share again. Now you get to see me hard at work. Come on. There we go. This guy right here. So my apologies for the rough deck, but and there's lots of stuff here, but I'm going to fly through it pretty fast, and feel free to ask. And the main thing that this is missing, which I'm starting to collect now, are better illustrations for what some of these terms are talking about. Let me single page. Okay. So the first digit in a PANOSE number is the script digit, which basically is what language are you talking about. And 2 has always been Latin. And so there was Latin, there was handwritten, there was iconographic fonts. So that was 3, 4. And somebody else was 5. Oh, Kanji was 5. And then 6 is now Devanagari. Also, all PANOSE digits kind of start with 2. There is a meaning to 0, and there is a meaning to a digit 1. So 0 means for some reason this digit just doesn't apply to this font, so that you can have an NA, as it were, a not applicable. And 1 was added for multiple masters, which is basically to say any is what the definition of 1 is. So there were some fonts that we classified for Adobe back in the day where their weight setting was any, because it was multiple master. There was a interpolation across the weight spectrum. So you could have width that would be any, you could have weight that could be any, you could have X height that could be any. So anyway, just to explain why I always start at 2. The serif digit is, for Latin, one of the most, I don't know, flavorful digits in the definition. And in Devanagari, it has a lot of flavor, but it isn't as strong in the overall shape of the font. So this covers both the way stems are terminated and a little bit about how the pen is used if you have a block pen or a sharp pen. What I've done here is this just came out of some other work that I did. So it mentions what the similar Latin PANOSE digit is, and this was done after looking at a number of different Devanagari designs, and again, Devanagari doesn't really use serifs, but it uses, you could think of the serif now as just being the way that the stroke is terminated. So it makes the most sense when you're looking at the Gothic square or the Gothic rounded. There's going to be a bunch that are that. If it's flared, meaning that at the end of the stem there's just a slight widening, which is kind of different than the pen sharp, which is when you have a sharp diagonal pen end to the horizontal or vertical strokes. And this, oh, there's also this C. You'll see these kind of throughout. So serif digit and then parentheses C. The C means that this attribute affects the contour of the character, and all PANOSE digits are either a C or a G. They're either the contour or the geometry, and so the geometry is such that it controls how the stems of the font are built in the space that it's building in, and the contour runs are then how the line wanders around those stems to build the font or the design that's being asked for. So that's number 2. This one's really simple. The weight digit, it's a contour 1, and it's the same. I think I will probably have slightly different variables. So these are the Latin variables, so that you can kind of get a sense for if you divide the cap height by the uppercase E stem width, that's what gives you the weight ratio, or the weight rat, as we called it. And I think Devanagari will have slightly scaled down numbers because the glyphs themselves are denser. So that's where that one ends up. Next one, proportion. Somebody just took my picture. Thank you. And hop that out.
We're going to post the slides, so don't worry about taking pictures.
Yeah, and so the proportion, that's a geometric one, and it has to do with kind of two things are in proportion. One is whether you have an extended or condensed face. So if you have a narrow font or particularly wide font, that would fall into those 5, 6, 7, 8, 9, or 5, 6, 7, 8. 9 is reserved for monospace fonts like Courier and line printers. And then there were, in Latin, 3 different areas where you would, where it wasn't extended, it wasn't condensed, but it had a different sort of ratio between the thick characters and the thin characters. And I'm using this for, 3 being kind of normal matrices and being modern, and 2 being script or hand-written sort of geometries of the face. And I think as I learn more, I'll want a 4th digit, so I just left one open. So that's what that guy was for. Contrast, again, is very similar between Latin and Devanagari. It's the ratio of the thickest part of the stem in the O to the thinnest. It actually goes back when you saw that little illustration that was in the previous deck of the uppercase O and had all those weird lines on it. Those were the measurements that are used to do contrast and roundness. Stroke speed. Stroke speed is a interesting concept. It only applies to curved characters, but what you'll see in kind of the typographic toolbox when you're drawing curves, you can make them slow curves or fast curves or instant curves. So think about an uppercase O like a Bedoni, where it goes from a very thin almost immediately to a very thick. And that stem, as it's coming around the curve, picks up the weight and then holds that weight all through the kind of more vertical part of the stem. That would be a rapid weight change. And there are some that are instant, where there's actually a corner on the inside of the counter where it goes from thin and then it hits a corner and drops down to give a very, very instant change in speed. So that stroke speed actually is something that I saw a lot of in the Devanagari samples that I was playing with, and so that will apply again kind of straight across. Stroke angle from Latin turns into curve angularity, or what some people refer to as turns. So there are some looping's the wrong word, some kind of fish hook shaped character elements, and how that hook is bent is very stylistically unique for the Devanagari kind of aesthetic and design. And so there's right inclined, which is really kind of what you get if you have a pen angle on the right. You have left inclined, you have vertical and horizontal. Horizontal is rarely used in Latin, but it was used much more frequently in Devanagari because you have that horizontal bar across the top that sort of sets the theme for having a horizontal pen design. Next, arm tapers become stem variations. It's kind of the same thing, but I wanted to include, in Latin, it was only looking at straight and diagonal stems, and in Devanagari it will apply to some of the curved stems as well. And that's just, most of the time the sides of an uppercase I are, it's like a steel beam, right? But then you look at a font like Optima or a number of newer fonts, and even subtly fonts like Palatino, where those stem edges are bowed slightly. If that bowing is enough to really affect the flavor and the appearance of the font, then it gets a non-straight stem style, which would be the same thing that happens in Devanagari. Counter closure. Arm terminals basically referred to the serifing or the termination of the uppercase C. If you think about that, the mouth of the C, does it look like it's laughing, or does it look like it's chewing, or does it look like it's, you know, grimacing? Same thing is true here. There's a number of loop counters that can either be closed or open. So that's why this one's listed as a G. It's a geometric change. You would have to, in our old system, we would have to have a separate glyph program for the ones that were open versus the ones that were closed, or else you get your winding order all screwed up. But that's how those guys worked. Letterform has to do with roundness, and the same roundness characteristics are true in Devanagari that they are for Latin. You know, this has to do with the shape of an O could be perfectly elliptical, but it rarely is. Most often, if you think of a font like Meanline, that's one that really pulls that O square into the corners. You know, it's not a nice round shape. There are very few that flatten the curvature less. Some do, but it generally is a really unappealing look. That same sort of roundness also occurs in Devanagari, and is a big change to the contour, and sets a lot of the flavor of the font. Obliquing, it's pretty simple. Is it slant or does it not? You know, the thing that's different is that Devanagari doesn't use obliquing necessarily for emphasis the way that Latin does. I forget what script I saw. I think it may have been Ethiopian, where they just kind of use obliquing all the time. It just sort of makes it look more friendly in their eyes. So we'll track obliquing. Now we get into a couple different things having to do with the layout of the Matra lines and how the overall geometry is actually composed. In Latin, it had to do with the midline. So if you think about the uppercase E, where's that bar? Usually it's a little bit above center. Some fonts put it really low to give a stylistic approach. Some fonts put it really high. Most fonts have it in the middle. The same thing is true for the Meanline Proportion. And I'm still working on exactly how to break this out. I need a little bit more information from someone who's done better research into Devanagari than I have at this point to figure out how those geometries should really be set out. And then in Latin, we have this apex trimming, which if you think about the font Cobble, that's a untrimmed apex, so that the uppercase A comes to an exact point, and the W has points that actually are like daggers through the baseline. A similar thing happens here with knots in Devanagari, and a knot is this corner shape, and sometimes those knots are open, and sometimes they're closed, and sometimes they kind of drag the shape over a little bit, and sometimes they even have a bit of a serif at the end of the knot, what I call footed. So we're trying to track those different knot variations, and you know, this will be a fun one. The next step on all of this Devanagari PANOSE stuff is then to figure out, how do we measure these things? What are the limits of what's been done in the typographic world for them, and how do we specify them numerically so that you can say, this is how wide it is, this is how tall it is. Then there's another Meanline Location. So I'm kind of ripping off the x height variable from Latin, because this Meanline is in the middle and really has to do with how compressed the upper third of the font becomes, whether it's tight, normal, or large, very large, or just sort of, I saw some that didn't seem to follow any rules, so that's cool too. We can deal with them. And then last, or almost last, there's this strange thing. It doesn't happen often in Latin. It also doesn't happen often in Devanagari, but there are times where, especially for display faces in Latin, what they do is when a capital letter needs an accent over it, they shrink the cap height. You see this most often in Northern European languages, where they have the angstrom over the A, and sometimes that sits up on top like a nice little halo, and sometimes it just jams the whole A down lower so that that circle can fit inside. The same thing happens with the Matra accent in Devanagari, where sometimes they just really don't leave any space for it, and things get pushed around when those upper accents are used. And then the last one is there is no 11th digit in Latin. And I've been toying with how to do this, and I just wanted to have a place to kind of track it for now. But Latin has a whole decorative classification system, and I didn't want to go that far with Devanagari for right now. But a big part of the Latin decorative set is tracking these treatments. So if it's a font that has a drop shadow behind it, or it's in relief, or it's inline or outline, which is contour, or whether it's has no curvature, or whether it's got a distressed edge, or whether it's reversed out, you know, those are valid fonts, and it'd be nice to be able to kind of track them and say, you know, it's either normal, and I kind of forgot normal there, didn't I? I should put normal in. So it's either normal or it's got some of these treatments on it. So that is kind of a quick view of where I'm heading with the Devanagari stuff. And like I said, illustrations will help a lot. I can't wait till we start to get in and measure these attributes and really figure out, you know, mathematically what's going on with these different ways of working. So I'll pop that off. I'm back. So any questions, any comments, any criticisms, any, you big dummy, what were you thinking? Most folks are muted.
Yeah. Hang on a second. I think that I'm not sure if people can unmute themselves. Let me try to force it.
There's one off.
So I'm clicking the unmute button, and I didn't know why it's not working.
Well, you're not muted. I can hear you, and I can hear Aaron.
Oh.
And I can hi.
And I guess as well.
And Nicholas and Pablo I can hear. So, anyways, so that's what we're working on, and the fun thing will be to see. Both this will be handy to help us just talk about the attributes of.
So actually, I have a question from Pooja, who's viewing but can't join the chat directly.
Oh, cool. Thanks.
So she asks, which letters have the hooks? She asked that about 10 minutes ago. I'm sorry.
Oh,
Where I was then.
I would have to get my sample guide out. I'm not well versed at the names of letters yet, so.
Okay.
But those will be samples, visual samples for the text.
Okay.
Other thoughts? Okay, I found the whole chat list.
Yeah. Okay. So, yeah, I mean, I think, let's see. Yeah, I think, that having a mapping of the existing PANOSE stuff is useful. To what extent do you know kind of existing PANOSE aware tools will be able to pick up on this kind of sixth script?
Yeah, I don't think that there are many systems. I don't think there's any systems that are embedded right now that would automatically know what to do with this. But it's, you know, there's good back history from PANOSE and from other matching systems for how to do weighted associations between disparate systems. And you know, back in the day, we did a lot of licensing of the PANOSE mapper, and that was interesting in that it wasn't just a simple one-to-one matching. All the different digits were weighted for their importance, and it was all checked for triangularity so that you wouldn't find, if this is close to this and this is close to this, then those two ends should be close to each other, and or at least the distances should be similar. And that took a lot of math to figure out how to make sure that those. And we didn't take it out to quads, but we had it balanced for triangles, which was pretty good. So, once upon a time.
Okay. Yeah, so there's a couple of things that I wanted to kind of show as relevant. Let me see if I can bring these up. So, so one is this D-square tool, and so this has been developed by Dr. Girish Dalby at the IIT Bombay Industrial Design Center, the IDC, and it's a Devanagari kind of type browsing application. So you have some filters here. There's a kind of hand and proportion sets of criteria, and then there's an advanced mode where there's even more things like this.
Wow, cool.
So you can select these kinds of things and then click Find Fonts, and then it will find fonts that match. So there's Satya's Kubanor. And so I'm not exactly sure how many fonts there are in total. I think if you click Reset and then Find Fonts, it gives us a big list. So this has got, quite a lot of stuff in it already.
Post that link.
Yeah. So so this offers. So this is based on Professor Dalby's PhD research, and he's offered to send a copy of his thesis to anybody who emails him. So I'll if you are interested in that, email me and I can make an introduction. But this tool provides most of the kind of theoretical results of the PhD. And then there's a terminology section which then explains with some illustrations about what they mean by, what Professor Dalby means by all of these. And so now that this is available, I think it would be very useful to be able to, for you then to kind of double check what you're classifying in PANOSE kind of matches the theoretical criteria in this tool.
That's great. Oh, see? Knots.
Is there maybe, I don't know about hooks. Yeah. So the about page also has some more information about it, and I think somewhere there's a there's a books and references section here. And, so this explains, this has got a long list of relevant sources which can be helpful, although I don't think that any of these are online when I look quickly. But yeah, so this is now a great resource, and if you have any other comments, if anyone has any comments about this, Girish is very keen to hear feedback about it.
Yeah, I'll take a look at it. It's great. Very pretty.
Yeah, so that's the first thing I wanted to show, and then the other thing I wanted to show you guys was that SIGGRAPH is going on at the moment up in Vancouver, and there was this very interesting paper presented in the typography section, which presents the idea of using some kind of manifolds to present the design space. So you can see that this paragraph, the font, every letter is kind of morphing, and the Knuth had done a similar thing. And then as you scroll down, then there's a 2D interactive version of this that allows you to kind of explore the design space and see the interpolations between different fonts. To select different glyphs and see them. And so the paper that's linked at the bottom has a lot of math in it and explains about what they've been doing there. Unfortunately, they don't mention PANOSE.
That's
slightly different, that there wasn't so many academic publishers about that papers. I think I knew was able to find one.
Boy, that's great. Can you post that link too?
Yeah, I think I just closed the window.
Oops.
There you go. All right. So yeah. So yeah. I've got to run off now. But I think this has been great to have this presented publicly. I think this is your story with PANOSE and Infinifont. The elsewhere story is definitely not well known. And as I say, these academic papers don't mention it as I think as a result of that.
That's great. Well, thanks for hosting, and if there's any other questions, I'm happy to answer. Alrighty.
All right. Well, yeah, I'll post the in the comments on the YouTube page.
Okay. Great.
All right. Thanks, everybody.
All right. Thanks. Cheers.
Thanks, Ben.
You bet.
Cheers.
Cheers. Bye-bye.